Hello everyone, I'm Yahya Bayramoglu, working as an Android engineer at Uber, as Mike already mentioned, and I'm going to be talking about independent features powered by Dagger Extensions. So knowing that focusing or keeping attention on the virtual conferences is quite difficult, I decided to start with live demo instead of finishing with it. So I'm going to show the end goal so you can have more ideas where we are going towards to, and maybe it will excite you a little bit more and then you can pay more attention. So I'm going to quickly switch to Android Studio and show the structure that what we are building. So we have a sample application, which I'm going to walk you through. We can think, you see here, I have a modularized application, which is like a base in the lowest layer. And I have feature 1, feature 2, which are depending on the base. And I have the application, which is depending on feature 1, feature 2, base, and everything. So, and the application is very simple. I really didn't pay much attention on how the design looks like, how the content it is. It's just like feature 1, here you go. Feature 2, here you go. Very simple. The interesting part, what I'm going to talk about, is the configuration, the setup part of this. Which let's assume that you have this application, which is a huge bunch of features, and one of your features end up, I don't know, low prioritized, and you want to remove it from the application, or it is so good that you want to extract it as a separate application. Or let's say you just don't want to bother with building the other features and you just want to build your own feature only. Especially this would be helpful when you're working day to day, right? So you're working on the feature 2, and you don't want to, deal with waiting for build time for all the other features and so on. So as you just saw, I removed the implementation of the project and just compile. That's it. That's basically all I had to do. I didn't have to go through the code and change anything, remove any imports, or remove some bindings or any code and clean up anything. It was just basically removing from the compilation, and the application works without that feature. That's simple. So now I'm going to go back to the slides and we will walk through how to get there. First, I'm going to start with an agenda because apparently people like it. We're going to start talking about why would you want to have independent features. And then we're going to see how the feature dependency structure is normally. And we're going to talk about the problem and how Anvil and Hilt solves this problem. I'm going to go step by step with Anvil and Hilt, showing the setups that we will have to do it. So it's going to be very fast talk. Buckle up and let me know if everything is going well. So starting with why would you want to have independent features? I'm going to explain this from two aspects. Is the technical aspect is you want to have a clear separation, right? This has already been told a lot while talking about modularization. I know there are conflicted opinions about modularization, but the clear separation, I think, is one of the things that is nothing to debate anymore. So that having clear separation is very important, that you actually abstract and encapsulate all your feature-related code in one place, and then you can actually make sure that this feature is completely isolated from the rest. This will help you this will force you, not help, put more thoughts on development while you're working on it, because you will not be able to just write a code that can access to anything, but you will have to figure out how to communicate between features, how do they need to do some abstractions, and how they would need to have public API and internal API and different things. And this will end up with having a less entangled code base, because you won't be able to, as I mentioned, access or refer to any other features code. So whenever you build some dependency, you would need to think whether this should be shared, or it should be feature specific, or it should be accessible from here or there. So you would need to think more about what you're doing and care about its accessibility between features. From practical aspects, it is for mostly useful for ownership, so that you have a clear owner of the feature, and you can, if something goes wrong, you can ask them, you can ping them if there's an alert system or whatsoever. You can even automate those things. It is easy to reuse, meaning that, as I showed, like you can just remove it and add it to another application and it will still work. And this features concept, what I'm talking is very high level. So if you have multiple applications, sharing a feature between those multiple applications is going to be a very important and practical task here. Isolated build, as I showed, that I could just remove and leave the feature that I'm working on and compile. This would give me a chance that I don't have to wait for compilation time of all the other features. If you have a big application, you know what I'm talking about. It is painful, and reducing the build time for only to your feature is going to be a huge win from day-to-day work. And if you have like a sample application in your repo, you can basically just enable your feature and try there. You can even use this as a sandbox, automate, maybe try to write your UI tests for specifically your feature, and so on and so on. Right. How about feature dependency structure? This is going to be mostly about a little bit of analyzation, how the feature dependencies are mostly structured. So you have your application, and most of the time you have certain dependencies that are shared during the application lifecycle, or that are has to be a single instance per application, or shared between the other features, right? And then you have your feature. So this feature will want to have some of those dependencies provided as an input, right? For example, retrofit. If you have a retrofit that you wanted, I don't know, single instance per application, then you can share between the features or any other operation related stuff, network layers or what, navigation layers, and so on. So your feature wants to have one of those application lifecycle dependencies, and then it will have its own self-maintained dependencies, which will be that feature creates those dependencies and feature consumes those dependencies, right? These parts are straightforward, and here is the tricky part. If a feature has a dependency that requires to be registered on application, or requires to have an application lifecycle, or requires to be provided in application but used in the feature, right? So this comes with a lot of hassle that with vanilla Dagger you might not be easily do it. And that brings us to the problem statement, why you cannot do it. So if you are familiar with Dagger, in vanilla Dagger, you have to define your component like this. If you have an application component, that means that will declare a bunch of modules that it needs to provide the instances for. And it will define the scope for it, application scope. This is the component, and these are the modules that is provided for. Some of the modules are shared, as I mentioned, like network module, Firebase, map provider module. These are samples. And then you have some modules that are only related to feature 1, feature 2, and so on, right? And you have to put them here if you want them to have application lifecycle, or if you want to have them some dependencies to be used during application on create or registration or initialization, so on. But this doesn't allow me to do what I just showed, right? So I cannot just remove it from compilation and try to build it, because it's going to say, hey, there is an import. I cannot access this class. And from where those classes are used or the instances are used, there's probably some logic going on there. I need to clean those up as well. So removing from the compilation is not going to be possible because everything is binded here. So what if we would have something like, okay, you define your static modules here, and then I don't know entire set of modules, but I know that there will be some other modules coming plug-in here. And then you say, whatever module defines this key, also consider them as part of this component, right? So this was a proposal I put up like 3 years ago. It got closed immediately because I wanted to have it integrated directly into Dagger, so we could have benefit. But now we don't need Dagger to have this because we have the Dagger extensions, which I'm going to talk about Hilt and Anvil and why they are called extensions, because they generate code that Dagger will use. So they are a step before than the Dagger's generation. So what's going to happen? They give us a little bit more flexibility that we can apply, and then they will generate code that Dagger can understand, and Dagger will generate the final code. So let's see how that works. First of all, why Anvil and Hilt that I'm talking about? It's definitely not because they are provided by Google or Square, very appreciated, but it's mostly about what do they bring to the table. They inverse the relation between component and module. As I showed before, in vanilla Dagger, component would define the modules that it will have, right? With Anvil and Hilt, it inversed into module defines where that it will be injected or used. So this will give us a lot more flexibility than it actually sounds, which I'm gonna show right now. So we're gonna start with Anvil, and I'm gonna show a basic setup, and then we're gonna build up with the showing more code examples how we're gonna do that. Our Gradle module structure is gonna be like this, as I showed on the live demo. Base module, feature one, and application. And the dependency structure, application depends on feature one depends on base. Please do keep this in mind because I'm gonna be mostly referring to these modules when I'm gonna be talking about. Here on base, we're gonna define shared scopes and shared abstractions so that every feature and application can have access to those. Feature one, we're going to define a feature scope, a component, and we will have a module that contributes to application component. On application, we're going to create an application component. There is a little red asterisk there. It's because it has to be on the top hierarchy if you want all the modules that are provided into to be compiled. And this is the same for Hilt. The application that you annotate with Hilt Android app, it needs to be on the top hierarchy, because that is the point that compiler plugin for Anvil start picking up, and then it will find application component, and it will go through all the dependencies and find the modules that needs to attach to that. So if you put it in base, which you can actually, there's nothing that preventing you to do. But if you put it in the base module, it won't have any module that you wanted to provide into it, and then the generated code will not be, well, it won't compile basically because you will try to access it at some other places, and the generated code will not have those dependencies. Yes, besides creating application component, we will also bind for the other components. So let's start. Here, I'm gonna have this squares representing the Gradle modules, and right bottom corner, you can see in which level that we are right now. So on the base layer, I'm gonna have the abstractions and scopes, as I mentioned. So I'm gonna start with application scope. In Anvil, scope definition is not tied to Dagger scope, but you can create any class. It doesn't have to be annotated as scope or retention and so on. But I'm gonna use it annotation for the sake of also being able to mark the life cycle of the instances that I'm gonna be creating. This is going to be an abstraction for us that we will use for feature dependency provider. I'm going to be implementing component dependency. That means every component needs to declare whatever they need from the parent component. And these abstractions will allow us to be able to retrieve those from parent, which I'm going to show how in a few minutes. And we're going to have a data class called feature, which defines a title and a deep link host so that we can navigate to. I do believe deep link navigation is a good approach, and this is considering this is a high-level concept for the features, high-level dependencies. It should be fairly straightforward to use deep links here. And the another abstractions that we're going to use is application plugin. I'm going to share more context later on, but the basic idea is that any libraries that needs to be initialized during onCreate of an application can be provided as application plugin, and in application level you get as a multi-binding set of these application plugins, and you just iterate on them and apply. So as I mentioned, I'm going to be using also multi-binding, and here we're going to have also a base module that provides a set of feature and set of application plugin. The reason of this is, as I showed, that I will remove one by one the dependencies, and whenever I removed, even if there was no feature, it should still be able to compile. So it needs to have an empty set by default. And if you see, the first annotation is called contributes to, and it has a key. The key is here called scope, which is the application scope class that I just created. This will tell Anvil to use this module on the component that is marked with application scope as well. That has the key of application scope. So moving forward, now we're going to go to one layer up on feature one. Let's see how are we going to implement all those things that we mentioned. So I'm going to have a feature one scope again for both marking the dependencies with the lifecycle and also making sure that we can use this for key. And as I mentioned, I'm going to use the component dependencies. So here is the dependencies that are required for feature one. And let's assume I have a shared instance for logging. Like it can be a timber or whatever. So I'm going to call it sample shared logger. And I say here, like, OK, feature one needs this one and the dependencies with app lifecycle to be able to create its own component, right? And you can see that there's annotation contributes to application scope again. This will make the component extend this interface or implement, depending on the type. Why this is important, I'm going to show it a little bit later. Just the important thing here is to keep this dependency with app lifecycle in mind. So on feature one scope, we have now feature one component, which has the annotation of merge component. This is also coming from Anvil. Anvil basically provides two most important annotations, contributes to and merge component. Merge component is going to be the entry point, and it will go collect all the contributes to modules that are using scope as feature one scope here and merge them into this component. And I'm also using dependencies as feature one dependencies. So whenever it needs to access to logger or the dependencies with app lifecycle, it will just receive from the parent. Right. So far was everything, as I mentioned, the straightforward. There is a base, there is a feature, all they provide dependencies. But now how about the dependencies that I mentioned that from feature one that needs to be provided to the application? There will be a few different type of application dependencies that I'm going to show. As you can see, my module name is very descriptive, feature one module to application. I have the annotation again, contributes to application scope. And this means that this module will be used in the application scope key, basically. I provide a feature instance saying that, hey, this is feature 1 here, and this is my deep link host, so you can navigate to me. The second instance that I'm going to provide an application plugin. I'm not going to show the code. You can see it on the repo if you're interested. It has some sort of initialization during the application on create that is required, and that's basically it. And the third one is a dependency with app lifecycle. We did have this as part of the feature 1 dependencies, right? It is because this module is going to be used on application scope component, which means if that is the parent, I have to retrieve that instance from there. Even though I'm providing within the feature 1 Gradle module, my Dagger component will not have access to it unless I provide it as a dependency, because it is defined on top. So another important thing here is I mark this as an application scope to have a single instance within the given scope. If you don't, as you know, that Dagger will create multiple every time a new instance within the same given scope. Right, last level is the application. And here we're gonna see now how all this thing comes together. We have an application component. I marked it as an application scope. And on the merge component, I say, hey, here is your key. Use the application scope and generate your code. Now I'm going to show what Anvil will end up telling Dagger to generate, right? Not the generated code by Dagger, but from Anvil to Dagger. So with that one line, 3 lines, yeah, 3 lines, Anvil will generate this code saying that, hey, this is an application component which extends feature 1 dependencies and feature 2 dependencies. I have 2 features. And in modules, it will define feature 1 module to application, feature 2 module to application, and base module. As I showed on the module, we have the contributes to annotation, right? That will all collect them into here. And it is also marked as application scope. Right, you can find this, it's not easy to find them because they are, Anvil is a compiler plugin, so it can be only used by Kotlin, by the way. In Kotlin classes, not necessarily fully a Kotlin project, you can have half-half, but you can still use it. So with the Kotlin compiler plugin, this will generate this code, and you won't actually see this, even in the generated Dagger code. But you can find this generated binary code, Java bytecode in a build temp capt tree and stops that path that I put up there. It is not as pretty as I show here. I simplified for you, but it has a lot of boilerplate around this information as well. So moving forward, now what we have is this sample application. And here I'm going to create my component, a Dagger component. Application is this. And then I'm going to inject a set of application plugin. And I have to get the component, inject this, and then access to application plugins, call for each plugin to apply. So that whatever dependency from whichever feature that needs to be registered or initialized, they can be done by here. And I don't have to know what are they. I don't have to care. It is provided by multi-binding, and it is coming from different modules that spread around. That is thanks to Anvil, so I don't need to worry about it. The last bit is the feature dependency provider. This is the tricky part. As I mentioned, I'm going to be using this for the create components for feature 1, feature 2, whatever. Because I need to have those dependencies from the parent, which is defined in the sample application for application component. So I make the sample application implement this because applications for Android are the instances that you can access from higher entry points like activities, fragments, and contexts, and so on, so that I can access to it and refer as a dependency provider. And what do I return here is basically the application component itself. And I'm typecasting because I know that if you annotated your dependencies class with the contributes to, it will be generated by Anvil. And if you didn't, then I'm going to throw you an exception saying, hey, you should use the dependencies to application scope. This is the only part that is actually a runtime problem. Unfortunately, it kind of requires such setup to be able to have this complete isolation. And this is not really, in my opinion, a problem since it is a high-level setup. You won't have further issues for dependency injection on static level, but it's only this part. And this is the same for Hilt, because I was curious like how this binding part happens for Hilt, and I would start digging into it. On entry points.get is the function. If you look at it there, it tries to retrieve the dependencies from different component providers, and all those component providers are actually mapped in memory. And if it cannot find, if something goes terribly bad, it will also throw exception on runtime. But as I mentioned, since Hilt comes with a huge set of setup already during compilation, they will also verify those parts in the compilation. So unless something goes terrible, it won't happen. Which brings us to Hilt. So for Hilt, I'm going to follow a different path. I'm going to show what we have just did and try to remove the parts that are not needed for Hilt. So this was the structure we follow for Anvil. And now if we would move to Hilt, we can remove from the base shared scopes. We don't need to define scopes because they are already defined in Hilt. We don't need to define a feature scope or component. You can, if you want, by defining entry point and different scopes and so on. But I don't think it is necessary if you're just following a similar approach. And then on application, we don't need to create a component. We don't need to bind anything. It will all be done just by annotating Hilt Android app. Right, so this was the abstraction, scopes, and everything that we introduced on base. For Anvil and Hilt, we don't need the scope because it's there. We don't need the abstraction of feature dependency provider because, as I mentioned, it's going to be handled by the setup itself. You don't need to worry about it. I'm going to keep the feature data class and application plugin for the sake of comparison on the same implementation. Base module is almost the same, just a tiny difference of annotation is installed in. A slight difference between Hilt and Anvil. In my opinion, Anvil has a little bit more flexible API because it doesn't require you to directly depend on the component, but you can just define a shared key between module and component. While here in Hilt, you need to tell in which component that it needs to install this module. So this application component here is actually the component itself. So whatever module you are in needs to know about the component where it's defined. Moving forward, we're gonna provide the features as we did in the same way, and the application plugin exactly the same way. For the depths with app lifecycle, it's the same way, just with a tiny annotation change. I use a singleton here because I didn't want to introduce a separate scope anyway. It's already part of the Hilt. It's already following everything that Hilt suggests, using singleton for application lifecycle instances as well, and so on. Right, moving to application. As I mentioned, it's going to be way simpler than I just showed for Anvil. You just annotate with Hilt Android app, and you inject a set of application plugins. And as you can see that I don't need to call, I don't need to access a component. I don't need to create it. I don't need to call inject or anything. It will just be done under the hood for me. And I go to application plugin and say apply. That's it. So that's basically all I have to say for Anvil and Hilt. They both bring a new perspective for Dagger. So do please consider different approach whenever you have any problem. Try to think out of the box now, because you have the tools even more flexible. Yeah, with all being said, I'm also gonna share some links to, if you are interested about modularization. I gave a talk last year, modularizing structure. You can find the slides there. And a similar talk, building features by independent Dagger components. This was 2 years ago. It talks about similar same concept with a different approach, because the Anvil and Hilt was not there. So I will walk you through within the problem and how far we can get to without having these extensions. So if you find this talk interested, you might also find that one interesting as well. The application plugin implementation I just showed, you can find a blog post about it here. You can read it, and there's also a sample GitHub project for it as well. And the GitHub repo for sample applications, I'm going to share the slides afterwards. You can get all these links, and you can also ping me on my Twitter, Yahya Bayramoglu. And thank you. I think if we have questions, maybe.
So thank you, Yahya. Yeah, we have.
Okay.
So, okay, one moment. Okay, perfect. Okay. Sorry. What happened? So I read the question. So, yes, what's your point of view on other dependency injection frameworks that are not Dagger, not Dagger-based, such as Coin or Codeine?
Sorry, could you repeat the question? I didn't get you. You were like. I heard coin and codeine, but I don't know what was the question itself.
Yeah. What do you think about Coin or Codeine?
Okay. So I did a little bit evaluation of different frameworks year ago, year and a half ago. By then, Coin was still using some runtime module modification, which I do believe I think is very important for having compile time safety and immutability in dependency tree. It's very crucial in my opinion. I created a ticket for Coin. I think they closed it, so it's maybe solved, but I didn't have time to check. I don't know the current state of it. Codeine is, in my opinion, a little bit further ahead. It was already multi-platform, and it is immutable. It is closer to Dagger structure, which kind of makes it a little bit more difficult to follow up as well, but it has an excessive documentation, but less community and advertisement, I would say. So they are fine. I would just say evaluate for yourself which one makes more sense in your case. But I think the compilation time safety is the biggest advantage for Dagger.
Okay, thank you, Yahya. Thank you for your talk, and see you later. Or yeah. I hope to see you in presence next year for the fest.
That would be great. Yes. Thank you, everyone.
Thank you. Bye bye.
Bye bye.